All right, welcome to this explainer. Today, we're going to completely level up your development game and absolutely eliminate the friction of working with Docker. Look, we all know containers give us incredible reliability and isolation, but let's be totally honest here. Sometimes getting them to play nicely during the local dev process, it kind of feels like running through thick mud. Well, we're going to fix that today. So, picture this. We've all been there. It's the ultimate shared developer nightmare. You make this tiny, microscopic code tweak. Maybe you just updated a single string or fixed a stupid typo. And then you sit there, staring blankly at your screen, while your container agonizingly rebuilds. You run it, test it, find another bug, and the whole painful cycle repeats. Honestly, if your local dev feels slower just because you adopted containers, you're stuck in the rebuild trap. Here's our roadmap for today. We're looking at 1. The container friction problem. 2. Level 1, mapping source code. 3. Level 2, auto-restarting code. 4. Multi-language hot reloading. And finally, 5. Level 3, line-by-line debugging. Let's get right into it.
Section 1, the container friction problem.
You know, every great game starts with a boss you just can't beat yet, right? For us, that boss is this naive approach. It's a 4-step trap. Step 1, you write or change your code. Step 2, you build the container image, which, let's face it, always takes too long. Step 3, you run the container. And step 4, you finally get to test the app. Repeating these 4 steps over and over for every single feature or bug fix, that is exactly what kills our productivity and completely drains our momentum. Just look at them side by side. Native development gives us that blazing fast, instant feedback we absolutely crave. But the basic container workflow, man, it is heavily weighed down by friction. Obviously, we want the instant feedback of native dev, but we still need the isolated reliability of containers. We shouldn't have to compromise, so let's start leveling up. Section 2, Level 1, Mapping Source Code. Okay, Level 1. This is where we defeat the need to rebuild the container entirely. Standard Docker file here. Notice how we normally just copy our source code directly into the image. Now, that's perfect for production for sure, but for local dev, it essentially locks your code in place until the next time you trigger a full build. Your container is basically holding onto a static, unchanging snapshot of your files. But here's how we bypass that lock. We use the volume command line parameter. By specifically mapping our present working directory, you see that PWD right there, straight to the app folder inside the container, we're essentially building a bridge. Now your saved code changes instantly appear inside the container. You hit save on your laptop, and boom, the file updates inside Docker immediately. 0 rebuilds required. Okay, rebuild, problem solved. But actually, scratch that. We aren't totally friction-free yet. Yes, the code updates inside the container, but the running application itself, the actual Node, Python, or Java process, it has no idea you changed anything. It's stubbornly running the old logic it loaded into memory, which forces us to manually stop and restart the container. Section 3, Level 2, Auto-Restarting Cone. To beat this level, we need the app to restart the exact second we hit save in our editor. Let's see how we tackle this for Node.js. We can literally just introduce a tool like Nodemon right into a custom dev Docker file. Check out line 2, we globally install Nodemon, and then on line 8, we swap out our boring standard node start command for Nodemon. We're actively building an environment designed specifically to watch for changes. And here's the magic in action. Nodemon actively watches your mapped files. The split second you save your code, Nodemon detects the change and automatically restarts the node server right there inside the container. We've actually done it. We've achieved instant feedback. You save your file, tab over to your browser, and the new code is already up and running. Section 4, Multi-language hot reloading. Now, I know what some of you are thinking. Well, this is just a neat JavaScript trick. Absolutely not. The crucial takeaway here is that whether you're coding in Java, Python, or .NET, there's a dedicated tool to get this exact same hot reloading magic inside your containers. The core concept is completely universal, it's just the tool that changes. Let's look at a few quick examples. Take Java developers, for example. There's no way you need to rebuild those massive jar files every single time. You simply drop the Spring Boot-develops dependency right into your pom.xml file. Once that's in there, Spring Boot takes over and will automatically restart your application context the moment classes on the class path change. Or look at Python. You can just toss debug equals true into your Flask app. Or get this, you can actually just use Nodemon. Yeah, Nodemon isn't strictly for Node.js. You can tell it to execute your Python file, and it'll watch your .py files, effortlessly restarting your Flask server automatically whenever you make a change, completely seamlessly inside the container. And for my C# developers out there, the tooling is baked right into the CLI. Just swap out .NET Run for the .NET Watch Run command inside your container, and you yield exactly the same automated, friction-free result. The application watches your project files and just reloads dynamically. Section 5, Level 3, Line-by-Line Debugging. All right, we've made it to the final boss fight, attaching a deep, interactive line-by-line debugger to an app that's buried deep inside a Docker container. To make this work, we first have to establish a secure comms line. Step 1, tell our runtime to listen for debuggers. Now, this is absolutely crucial. It must listen on all IP addresses using 0.0.0.0, not just localhost, because remember, it's inside a container network. Then step 2, we map that specific debug port, like 9229 for Node, out to our localhost machine so our IDE can actually grab it. Then we set up our IDE. By configuring an attach request, like you see here in this VS Code launch.json file, you can hook your editor directly into the running container. It's wild. You can set breakpoints, inspect variables, and step through your code exactly as if the app was running bare metal on your laptop. Okay, and here is the ultimate pro tip to tie this whole shebang together. If you're using Nodemon to auto-restart, your debugger is going to brutally detach every time the app restarts. Super annoying, right? But by simply adding restart true to your launch.json configuration, the debugger will automatically reconnect. This means you can change code, watch it auto-restart, and keep your deep debugging session alive without missing a single beat. So we've officially conquered the naive workflow. You now have the ultimate blueprint to eliminate rebuild friction. You know how to map volumes, leverage hot reloading across pretty much any language, and hook up deep line-by-line debuggers. So my question to you is, how are you going to refactor your local dev setup today? Are you going to stay stuck in the rebuild trap, or are you going to accelerate? Thanks so much for hanging out with me on this explainer. I hope you use these tools to go build something amazing.